All right, so a molarity problem, it's going to read just like this. So we are, so you can pause it real quick and write this down. We're going to add a few things to this. First of all, the thing that you need to know is molarity actually stands for moles of solute per moles of, not moles, I am so sorry, moles of solute per liters of solvent. So molarity problems are some of the easiest problems because all you need to know is moles of solute per liters of solvent. That's what this problem is going to ask you to find. It says, what is the molarity of? You can also see these as how much is the concentration in molarity, right? You know, that sort of thing. But this is the general layout of these kinds of problems. We have something dissolved in something else. So the first something that is getting dissolved, that is the solute. And you're going to notice it's usually in grams, dissolved in blank liters of water. So that is our solvent. So what we're going to do is we're going to set this up using good old factor label. Now, there are ways to do this using algebra, but for me, it involves a lot more steps. I don't like to do the algebraic method. If you want to learn the algebraic method, lots of folks go through that online. You're welcome to go watch another YouTube video on how to set that up algebraically. I'm going to do this problem. I'm going to do it using the factor label because that system works every single time. And later on, when we switch it up, you're going to see the algebra method gets a lot more difficult. So I'm going to be doing this one. There is one change I'm going to make to my factor label here, and that is I'm going to start with my answer. All right, and the reason I'm going to start with my answer is when I look at this problem, remember, every time we've done factor label, there's only ever been one number in this problem. There are two numbers in this problem, and that makes this problem that much more difficult, all right? So what I'm going to do is I'm going to jump over here, and I'm going to put moles per liters, because it asks me, question mark, what is the molarity? And I'm just going to automatically, in my brain, I'm going to convert molarity to moles per liter. If I can do that, my life is 10 times easier. So now that I know that goes out here at the end, let's look at the problem. Which of these would I like to put first on the line? And hopefully in your brain, somebody's already jumped to the fact that, hey, I can convert grams to moles. I know I can do that. We did that a couple of weeks ago where we talked about you take grams and use the molar mass and you convert to moles. If your brain wants to start there, that's fine. Or you can do the easier thing. You can realize here's liters, right? We've got liters in the problem. We need liters on the bottom. So I'm going to start by writing liters on the bottom, 0.223 liters of H2O. So I'm going to put H2O on there. Perfect, right? Goes on the bottom, check. What goes on the top, then, has to be the 26.2 grams of calcium chloride, CaCl2. Boom. Easy, right? When I look at this, here are my units right here. It's going to be grams over liters. That's not what I want. I want moles over liters. So I need to change that grams into moles. So I'm going to cancel out the grams. If I'm going to cancel out these grams, where do they have to go in this second step? Grams has to go on the bottom. And it's grams of calcium chloride. And hopefully you pick this up when we're doing those mole conversions. If I've got grams on one side, I can easily put moles on the other side, but it's got to be the same substance. So I don't want anybody to fall into the trap. You'll see a lot of students fall into the trap. They're like, well, it's got to be H2O. No. Remember, I can only change one of these things on each side, right? If I go from grams of calcium chloride, it's got to be moles of CaCl2 on the other side. I can't go from grams of one thing to moles of a different thing. And you're going to see on these problems, it's not such a big deal, all right? So how many grams equals how many moles? Well, for that, I need my periodic table of the elements. And so I'm going to get me a ptable.com right here. And we're going to remind ourselves one more time, just one more time. This is why we spent so much time on this. Calcium is 40.08. And there are two chlorines. They're both 35.45. So 4008, excuse me, I'm plugging them into my calculator right here. 40.08 plus 35.45 times 2. Because if we remember, when we jump back over here, there are 2 chlorines, so we got to remember to multiply that one by 2. And I get, it is 110.98 grams of calcium chloride. What goes in front of moles? Oh yeah, a 1. Hopefully you remember that from the test. What cancels out here? Well, we cancel out gone. Gone. Grams of calcium chloride's left out. And I'm left with only moles on top and only liters. And a lot of people are going to freak out. They're going to say, hey, before, you only ever had things on top. I know, but notice over here, right? Our answer needs to be in a ratio of units. It needs to be moles on top, liters on the bottom. Some folks find this a lot easier than they did the other ones. So now we plugged in 26.2 times 1 divided by 0.223 divided by 110.98. Don't forget, divide by each thing on the bottom. And I get a molarity, the answer back in black ink here, 1.06 moles per liter. Now, if it really bothers you that you left the units off, you can add them. Calcium chloride, liters of H2O. That's fine. That's fine. You can add those back in there. That's totally cool. All right. That's how you do a grams, liters to molarity problem.